Hey students, as you can see, I'm at home right now. So what I'm doing is I'm just showing you the setup for an experiment that I've been testing out at home in the last few days. So let's take a look. So as you can see here, I have two bottles of mung beans, okay? Two bottles of mung bean, and I've been germinating them since Saturday. So this is, it's been 2 mornings now. It's been 2 mornings, actually more than 2 mornings. Yeah, I set it up on Friday. So actually this will be the day number 3. So in this case, as you can see, I've put a number of mung beans in here. Originally they're dried, of course, and then I added I used toilet paper, about 1 square, and I use about 4 or 5 squares of it. I basically drip it in water, the toilet paper, 1 cube at a time, and then when it's wet, fling out the excess water, and then just drop it in here, and add a little bit of water underneath. And basically during the regular time, I would leave it close simply because, as you can see, it does build up the humidity. It's actually quite important in the beginning of the germination process that the atmosphere or the environment is humid. Then you would actually get the germination process going quickly. Now, so this experiment is actually to measure the respiration rate of germinating mung beans. Mung beans do grow really quickly, and as you can guess, it has a pretty high respiration rate because it's burning the energy that's storing inside the bean, right? So we have two ways to measure it. You can either use a Vernier oxygen gas sensor. The one that we have, you can directly plug it into the laptop. I'm not sure whether you can work it on Chromebook or not. I still have to test it out and see. Or you can use a carbon dioxide gas sensor. And for this one, we do have to plug it into a LabQuest Mini. And then we're going to plug it into a computer. Okay, this computer have now both computers. We're gonna run Vernier graphical analysis. It works quite well, and so for this computer that have the oxygen probe directly plugged in, I'm just gonna go here, and then I have to launch, and then I launch app. It looks like this, but in a few minutes time, it loads now. And as you can see here, you have oxygen, gas. And on this computer here that has the LabQuest Mini, I do have to download the Windows version of the LabQuest Mini so that of the graphical analysis so that it will run. Now, this video is to talk about how you're gonna do the experiment. I'm gonna talk about the experimental, how to use the graphical analysis in a different video. So typically what I do, you actually have to unscrew. Now these things weren't really screwed in very tightly because you do want airflow to go in, but you just want to minimize the amount of humidity lost to the atmosphere. So you have to open it up a little bit and let the air flow a little bit for about 2-3 minutes before you put the probe in. Okay. Now this bottle I've opened this bottle a little bit earlier to allow the airflow, so it should be closer to normal. Now what I'm going to do for this oxygen sensor, you do the same thing for the other one too. Oxygen sensor, you're going to put this directly into here. It should fit snugly. I'm also going to see whether this will fit directly on a 250 ml Erlenmeyer flask, and then we'll let you know. So now on this here, I'm going to set it up. So if you press this button, I'm going to see meters. so I can see the meter going on, and I'm gonna see data table. And what I'm gonna do, now oxygen gas, you do need to have it set so that, I'm gonna click here, I'm gonna have, oh, not that point. Oh yeah, I'm gonna click here, and I'm gonna have the units of oxygen gas to parts per million. Okay, parts per million, it is a lot more sensitive than percentage, and it is also a recognizable unit. It's called parts per million. And what we're gonna do is I'm gonna change the setting. So it's going to be 25 seconds per sample. And I'm gonna have in collection basically about, in this video, I'm gonna put 600 seconds, but follow my instruction in class so that you can see what we're gonna do if I have a different time frame. Press enter. Now, in this case, since this has been running for a few minutes, airflow has happened before I put this sensor in a few minutes. So what I'm going to do is I'm going to get a start now. So I'm going to press collect. Okay. And as you can see, it's taking a reading here already. And for every 5 seconds, it will take a reading from here. I'm going to go and set this carbon dioxide bottle up for the second bottle. And I'm just, now, the carbon dioxide sensor, it's different in the sense that, let's try to get a focus. You have 2 possible readings. Let's see, put here so I can focus. Okay, so you have 2 possible settings. You can have low, which means go from 0 to 10,000 parts per million, or you can go from high, from 0 to 100,000. Now, yes, originally when I started the experiment, I actually have it set low, but what I did notice yesterday is that, and this is day 3, yesterday after day 2, I have to go to the higher setting, otherwise it's not going to record. So right now I have the higher setting. You will have to pay attention when you start to experiment what kind of numbers you are getting. What kind of numbers you probably have to start low and then after a day or 2 turn high. Okay, but right now, because I've been doing this for 3 days now, put it in the high setting. Again, I'm plugging it in like this. I'm just putting on the side, just make sure this doesn't topple over. And same setup. For the other one, I'm going to go to meters and data table. Now you can see this is climbing up pretty quickly. So, and since the airflow has happened, like it was about 4 minutes since I plugged it in and opened. So I'm gonna get started again. Oh, make sure this is 25 seconds per sample. And right now 600 seconds. Okay, so I just get started. Collecting now. And I'm gonna check in with you in a few minutes.